Welcome. This video focuses on using functions to make modular maintainable code. So the first thing we're going to look at is comments. And why these are important? Well, functions are designed to do two things for us. One, to allow us to reuse code, so we don't have to copy and paste chunks of code all over. We can just put the code in one place, build it, test it there, and then reuse it. And then two, to be an abstraction, so that we can think at a higher level as we're problem solving. Right? We do this with when we're using the string functions that are built in. We don't want to have to stop and think about how something like string.find works. We just want to know roughly how it does it, or what it does, and that we can call it and get back an answer to, hey, where can I find this within a string? And not worry about exactly how it's working. Now, for that abstraction to work, we have to have a way of deciding how a particular function operates from the outside, kind of as a black box. And comments are designed to help us do that. So say I've got a function isPrime. Just looking at the function prototype, I can see that it's called isPrime, it returns a Boolean, and it takes in an int that it's going to call number. Well, comments are a way to add some information about those pieces. And this style of comment with the @ symbols and then the special tags is called Doxygen format. It's the same thing we're using at the top of all our files. But now we're going to start adding it before each function to give a brief description of what the function does, a description of each parameter. So number at param number is describing this particular parameter, and then a description of what it's supposed to return to us. And adding these comments in Qt Creator is very easy. If I just type /** and hit enter, it's going to fill in placeholders. So @brief is just supposed to be a description of this function. I don't need to have the function name there. I'm just going to put returns true if given number is prime. @param number. So this is going to be what the heck is number. This is the integer to test. All right, I'm just describing that piece of information, and at return I'm describing what gets returned. We return true if number is prime, otherwise false. All right, so we do something like that. In this way, if a programmer comes in, they don't have to look at our source code. They can just read this function prototype and the comments and hopefully figure out how the thing works without going and kind of reading line by line to try and understand the function. Not only that, but because they're in this special format, we can use tools to extract them. And so one tool we can use is called Doxygen. And you can Google it and download it and install it. If you're on a PC and you install it, and you've installed my templates, then you can fire it up from within Qt Creator by going to Doxygen. If you're not on a PC, you can just fire up the program itself, and all you'll have to do is go manually select where your project folder is. So since I fired it up from within Qt Creator, it's already got the project directory selected. I'm just going to tell it to scan all entities and to include the source code. And now I'm going to tell it to run. And it chugs for a little bit. And now I can show the HTML it generated. So this is the web page it generated from my source code. And I've got one file, main.cpp. If I go look in there, right, it's documented all my functions. isPrime returns true if given number is prime. I can click down and it shows me the brief description I typed in, the information about the parameter number, what it returns, it tells me where it's defined. I can even go look at the source code. Right, kind of a real cool way to build documentation for a project without having to kind of maintain this by hand. We can automatically just extract it from the source code every time we make changes. So you don't have to do that unless you want, but it is kind of a fun, cool toy to play with, and it's why we bother with this special format. So the next idea is the idea of a function prototype. And this is declaring a function without actually defining how it works. So that isPrime function, if I write bool isPrime int number semicolon, and I don't have the curly brace and all the code for it, I'm saying, hey, this function's going to exist. I'm just not defining it yet. And the advantage of that is if I declare the functions, basically I'm promising, hey, these functions are going to exist, I can move them around. So right now, my isPrime has to come first because it's used by print and count primes right here. And print and count primes is used in main, so they both have to appear before main. If I try and move them to the end of the file and build this, it's going to tell me, hey, I've never heard of print and count primes. So the way I can get around this is to declare my function. This is basically just promising, hey, this function's going to exist. And I'd probably put the comments with that part. And do the same for this other function. Alright, and I should put comments in for that. I'm not going to stop and type them, but should have comment in for that one. And now I can rebuild, and it's happy. When it gets to main and it starts trying to compile the code, it looks at the print and count primes and says, well, I don't know how that thing works yet, but I've been promised that that function exists and I'm going to see it at some point. And so it's able to build that kind of using what it knows about the function. Now, if that function doesn't end up existing, right, so say I left out the isPrimes and I try and build it, I get this error about undefined reference to isPrime. And what that's telling me, actually anything that says LD is the linker. So this is saying, well, I went through and I compiled all the pieces, and now I want to put them together, and you promised me I'm going to see this isPrime function, and I never saw it. If I put it back in, right, we're back to being fine. So these prototypes allow us to move the function definitions, all the code for it, away from where we declare it, where we just promise it's going to exist. Now, we can do that within a file, but we can also go make a separate function library. And this is what you see when you go and get code from someone else. Generally, it'll come in two pieces. There'll be a collection of functions for you to use, and that'll be stored in a C++ file, CPP file. And with that will come a header file. And a header file basically has all the declarations for what functions there are, and usually we'll have the comments, and it'll have a .h extension. And that's what we include in our code. And then kind of separately, we leave the actual function definitions alone in a separate file. Okay. This is essentially what we're doing anytime we include something like CMath. We're saying go include this header file, bring in all the function definitions that are within the CMath file. So we could do the same thing. We could package these up, the isPrime and print and count prime, into a header file and just pull them completely out of main.cpp. So basically strip this down to just main. And that way we could maybe reuse these functions in another project, or just kind of break things up. If our main file is getting really huge, we might start breaking it into separate files. So the way we do this is we go make a .h file, and then we include it just like we include the standard libraries. Only if you're including your own .h file, you use quotes instead of the brackets. Basically, the brackets say go look for the standard library with this name. The quotes say go look for my library with this name. So I'm going to do that. We're going to add a new file. The type of file I'm going to add is a C++ header file. And I'm going to call this prime lib prime.h, and it puts it in the project folder and also includes these guys. Those guys are called header guards, and basically they make sure that we don't by accident include a chunk of code twice. If you kind of redeclare the same function multiple times, the compiler's not going to be happy with you. So what we want to do is just have this only ever appear once. And why would we include it twice? Well, we wouldn't do that intentionally, but this is really easy to have happen. If you include libraries A and B, and library B also includes library A, well, now you've got two copies of A, right? The one you include yourself and the one that you didn't realize B was going to include. So these statements, remember anything with a hash symbol in front of it is handled by the preprocessor. So it's going to come through and say, if I've never seen prime stuff H, then define that so I know I've seen it, suck in this code, and here's the end of the if. So the first time we define all the functions. Next time we check, hey, have we not defined this? No, we have. We've seen this. So we're going to skip all this stuff. So we can just put whatever functions we want to declare in there. So here's where I'd put all my function declarations. Right, this is kind of what my library contains, is prime and print and count primes. Then in main, I can include primelib.h to say go suck those definitions in, and if I build it, it's happy. All right, it hasn't seen print and count primes directly here, but including that library means it sucked this in and has heard about the function. Now normally we wouldn't leave the function bodies in main. The whole point of this is to kind of break things off. And so what we'd do is with primelib.h we'd have a .cpp file. So I'd add a separate C++ source file and usually give it the same name, primelib.cpp, just different extension. And I'd go take those two functions and put them in this separate C++ file. Now it has to stand alone, right? Because I'm using cout. It needs to include iostream, and I'll include the namespace. So basically, it has to stand alone and have all the definitions it needs. Oftentimes, it would include its own .h. And so that way, if I want to rearrange the order of these functions, they've already been declared. But so this is basically a standalone piece that I could kind of easily take those two files and move them to another project, or just link to these copies. Main, what it's going to do is include the primelib.h, and that's how it finds out what functions are going to exist. And then the project is set up to include both these files, so it's going to compile them separately. And then the final step will be to link them together, and that's the point at which it tries to match up. Okay, I was promised there's going to be this print and count primes, and oh, this guy's got this print and count primes, so I'm going to hook those two pieces together. And as long as everything you've promised in the .h file ends up being found somewhere, then the whole thing works out. And our main file can just worry about the job it's supposed to do, and the code that's kind of special purpose for dealing with primes can be off in this other library.